In this lesson, we are going to learn how to simplify expressions that use a zero exponent. We are also going to learn how to simplify expressions that have negative exponents. We know that 4 to the third power can be rewritten as 4 times 4 times 4 equals 64. 4 to the second power can be rewritten as 4 times 4 equals 16. And 4 to the first power is 4. So what might 4 to the 0 power be? The answer is 1. But why? In a previous lesson, we learned about the quotient of powers property. This property said if we were dividing like bases, we could subtract the exponents. So we would have 4 to the 7th power divided by 4 to the 3rd power would equal 4 to the 7 minus 3, and that would equal 4 to the 4th power. What happens when we have 4 to the 3rd power divided by 4 to the 3rd power? If we write this out, we would see we have 4 times 4 times 4 divided by 4 times 4 times 4. We would have 64 divided by 64. That equals 1. This matches our power from yesterday with the quotient of powers property. 4 to the 3rd power divided by 4 to the 3rd power is 4 to the 3 minus 3, or 4 to the 0, which would equal 1. This is the definition of zero exponents. Any number other than 0 raised to the 0 power is 1. Let's try some examples. In example 1, we have 17 raised to the 0 power. That's like saying 17 divided by 17 is equal to 1. Sorry, 1. In our second example, we have negative 4 to the 0 power. That's like saying negative 4 divided by negative 4 is equal to 1. In our third example, we're combining rules. We're using the power of the product property, which states we can apply the power to all the factors inside. So we would have 390 raised to the 0 power times w to the 6th power raised to the 0 power is w to the 0 power times g to the 17th power raised to the 0 power is g to the 0 power. That means we have 1 times 1 times 1, which is all equal to 1. Now we're going to talk about negative exponents. Another way to kind of think about positive exponents is to think of them as how many times 1 is multiplied times the base. Here our base is 4, and 4 to the 3rd power. So we would have 1 times 4 times 4 times 4 equals 64. What might 4 to the negative 3rd power be? Our answer is 1 over 64. But why? Let's look for a pattern. 4 to the 3rd power is 64. 4 squared is 16. 4 to the first is 4. And 4 to the 0 is 1. We know to go from 1 to 4, we multiply by 4. To go from 4 to 16, we multiply by 4. And to go from 16 to 64, we multiply by 4. So how do we go backwards? How do we go from 64 to 16? We divide by 4. 16 divided by 4 is 4. And 4 divided by 4 is 1. So if we want to keep going and use our pattern, 1 divided by 4 is 1/4. 1/4 divided by 4 is 1/16. Another way to think of dividing by 4 is by multiplying it by its reciprocal. So instead of saying 1/4 divided by 4, we can say we have 1/4 times 1/4. This 1/4 is the reciprocal of this 4. Just like the multiplication is the opposite of division, 1/4 is the opposite of 4. This is true for all negative exponents. You can think of negative exponents as taking the reciprocal. You can also think of it as when you have a negative exponent, you have to move the power to the other side of the division bar. Let's try some examples. In example 1, we have 3 to the negative third power. Notice that 3 to the negative third power is in the numerator. It wants to move to the denominator, making it 3 to the positive third power. So we have 1 over 3 to the third power. In number 2, our negative exponent is already in the denominator. To make it a positive exponent, we have to move it to the numerator, making it 4 to the second power over 1, or just 4 to the second power. Our rule holds true even for negative bases, like this -2. Here, our negative exponent tells us it has to move to the denominator. But we're going to keep the base the same. It's still a -2 base. It just changes from the numerator to the denominator, and the exponent changes from a -3 to a +3. In our last example, notice we are multiplying two factors, the 6 and the x. But only the x is raised to the negative exponent. That means only the x will move. Only the x will go from the numerator to the denominator. The 6 will stay where it is, up in the numerator, giving us 6 divided by x to the second power.